Welcome, guys. Thanks for coming. Just before we start, I guess, before we actually go live and anyone's actually really watching, to help us warm up, tell us about the worst hotel room you've ever stayed at. Where was it? What happened?
For me, it was not a hotel room. It was a motel room.
Motel, yep.
Timaru, many years ago when I was a travelling salesman. Yep. And this particular room that I stayed in, you open the door and the odour was overpowering. And by odour, I mean the odour of, I suspect, men, heavily cologned, a lot of pheromones, a lot of richness that has seeped into the walls in the bed and concentrated particularly on the pillow. People doing their job, I guess, much like myself, and I potentially contributed to it. But that was quite memorable for me.
Yeah, I think you could bottle it and call it Old Spice. Yeah,
you could have.
Are you, Thomas?
I've actually heard about hotel disgruntled staff members leaving presents in the hallway, thinking that they wouldn't be caught, and through the CCTV they could see the staff member taking a crotch and a crouch in the corner.
Oh, fantastic. We stayed in this hotel once. We went to a friend's wedding many haircuts ago in New Plymouth. Nothing against New Plymouth, great place. And the hotel was economical, if you like, and the whole wedding party was staying there. And the room we had a very worn-in bed. For some reason, the springs were skewed to one side. And sort of 4 or 5 times a night, the mattress would just walk off the bed by itself, you know. And then the next morning we woke up and we realised that all the hot water was linked off one source. So the people that got up before us and ran their spa bath ran us out of hot water. So
Nice.
Fantastic.
I consider it.
Excellent.
Yeah, hotels. So today's topic is how to specify a robust warm roof solution. We're going to illustrate that warm roofs are becoming more and more common. They're becoming the norm. And it's really important that we specify a robust system. So with me on the panel today, I've got Scott Squire, who's our specification manager for Nuralite. Welcome, Scott.
Thank you, Shane. Thanks for having me.
No worries. Haven't got much choice, so
That's what I'm paid to do.
Exactly. And we have Thomas McLaughlin, who is the Managing Director of ILD, or International Leak Detection. Thanks for coming, mate.
Hey, no, thank you for having me.
So you've been doing this a while?
Yep, since 2013. So, I've seen a lot of changes in the membrane, and, a lot of them for benefit of the building industry and some of the things that seem to trip us up over and over.
So your job wholly and solely is to go out and inspect membrane roofs, yeah?
Yeah, that's right. Not always the most exciting topic, but I just see how they really get treated in the real world.
Yeah. So you inspect them, you don't install them?
No, just purely sort of see what's left after everybody leaves, really.
Yeah, right.
Yep.
No, it's great to have an independent third-party tester, I guess. Why we think today's webinar is important to you is that recent changes in the New Zealand Building Code around H1 thermal efficiency have driven designers towards warm roofs. They're becoming more and more popular. 10 years ago, they're probably 5% of our business. Today, they're probably about 50% of our business. Additionally to that, MB are planning some significant changes to legislation around accountability. So they're going to be moving from joint and several liability to proportional liability. So we think it's really important to our designers and builders, etc., that we design robust roofing solutions. Other changes MB are looking to insert professional indemnity insurance, disciplinary penalties. I mean, even the fees to be an architect are increasing. So anyway, so if there's one message we take away from today's presentation, it's that Nuralite can de-risk your warm roof. We're going to touch on 3 aspects today on how we can de-risk the warm roof. We're going to talk about mechanical fixing, or the type of fixing. We're going to talk about insulation choices. And then last but not least, we're going to go into a bit of a deeper dive around electronic leak detection from our friends at International Leak Detection. All right, so before we go into those 3 aspects about creating a robust warm roof, let's just quickly recap. What is a warm roof, Scott?
Yeah, so historically, in terms of membrane flat roofs, typically you're just putting membrane onto a plywood substrate and then filling the roof cavity with a lot of fluffy insulation.
Yep.
a warm roof, we're essentially taking the insulation layer, putting it on top of the roof,
Yep.
membrane on top of the insulation. So taking insulation from inside, putting it outside to where we believe it should be, and
Yep.
the science shows it should be there. That does a few things. It helps to manage condensation risk, and it also gives you a really nice uniform layer of insulation, so you get good thermal performance, which,
Nice.
thinking about H1 is about insulation. It's also about limiting uncontrollable airflow,
Yes.
and part of our system has a vapour barrier that goes under the insulation, so it kind of ticks those two boxes.
Yeah. So we've got an image here of the warm roof. Just want to quickly run through what we're looking at here. Just so you talked about that vapour layer, the air layer.
Yeah.
What is that?
So that is the silver layer that you can see there on top of the metal tray.
Yep.
And that's self-adhered. And then you've got PIR, that's PIR insulation board.
Mhm.
And then you can see we've got a 2-layer membrane on top. So thinking about warm roofs, it's all about control layers. You know, you've got
Yep.
the membrane on top that sheds water. You've got the PIR, thermal control layer. And then the vapour barrier, that's your air vapour control layer. Yeah.
Nice. And I guess warm roofs aren't new to you either, Thomas. You've done this for, I've forgotten how long you said, 12 years? 15 years?
long time.
Long time.
But the difference with it for us is then, because we're involved after that design part, and when it is in the construction phase and post, we see that there is an interaction between the construction site and the membrane. It goes down so early in that process.
Yeah.
And how does the construction site interact with that membrane?
So part of your detectoring services is you can detect the warm roof or inspect the warm roof as well. Treat it as a membrane.
Verify that.
Yep.
Verify that water tightness.
Nice.
Yeah.
Okay, so the first key aspect of how to build, or how to design and build a robust warm roof, we think, is the take into consideration the type of fixing, the holding it all together.
Totally.
So you want to talk about our type of fixing we do?
Yeah, our preferred method is mechanical fixing, 100%.
Right.
In fact, if you download any of our details from the website, it shows these things here,
Yep.
an IcoFix fastener.
Great.
We offer adhesive fixing as well,
Yep.
but 99% of the time we say mechanically fix, and that's going to de-risk during construction.
I mean, it's a rare situation where we would advise gluing. One situation might be a heated indoor swimming pool, for example, where we try to eliminate every single point of thermal bridging. But they're few and far between, unfortunately. So 99% mechanically fixed, yeah?
Totally, yeah.
Cool.
And
Yep.
in terms of building sites, how often would you see a building that's shrink-wrapped?
All the time. It's
It's more
pretty prevalent now.
pretty common?
Yep.
Yeah.
And doesn't come with that stigma of the leaky building anymore. Now it's the way we build.
Yeah,
right?
it makes
Way
sense,
to build.
right? Yep.
Yeah, which is
Yep.
really good. And shrink wrapping the building means that you're taking out a lot of those elements that otherwise, if you're trying to install a warm roof in the exposed weather conditions, there's a lot of risk, right?
Yeah.
You've got dust blowing around if you're using adhesives.
Yep.
That
Temperature
means
fluctuations,
Yep.
all that sort of stuff.
temperature spikes,
Yep.
ups and downs. Mechanical fixing is such a simple way to install PIR board. The installer follows a standard pattern. They're not having to work with adhesives. Adhesives obviously are affected by
Yep.
different conditions in terms of curing time.
Yeah, I mean, we know from our experience that there's certain months of the year you simply cannot use adhesives in the South Island, for example.
For
So-
sure, yeah. So we have a thing which is called an IcoFix fastener,
Yep.
and that's one part of it. It's a thermally broken flange. So in terms of that, coming back to that insulation control layer, if you start putting metal fixings through it, straight away you're eroding that thermal performance that it's there to provide. So by using this, what you do is you do offset a degree of the thermal bridging, the thermal loss.
Yep.
And then we have a screw fixing, which you can see in the render here. And the screw fixing is typically a pretty static, standard size. But the beauty of these flanges is we can import these in super long lengths,
Yep.
so we can accommodate really thick build-ups of PIR,
Yep.
which means then depending on your target R value, you've got flexibility. But yeah, in terms of simplification, that's definitely the way to do it. It's fast to install
Yep.
and really easy. Yeah.
And I guess one of the other benefits of mechanical fixing as well that I've seen is that, we're sort of trying to design for that, if the worst does happen, So if there is water ingress at some point during construction, because we've screwed it, we can actually simply unscrew it and replace the damaged boards and things like that. Whereas you can't do that with a glued system if the glue's stuck to everything. So
Yeah.
a couple of advantages to that system there.
Yeah. Another thing to think about is wind pressure.
Yes.
We're seeing with climate change, facade engineers, we're seeing a lot of roofs being designed with really significant wind uplift, and adhesives work to a point. With a mechanical fixing, our standard pattern, you can go up to 4 kPa ULS.
Yeah, as a standard.
As a standard. Anything over and above that, you're just adding more fixings, basically.
One of the things using a full screw, the full length, the other thing this does is, like, if you impact on that screw, you can actually push the screw out through the membrane.
Yeah.
I don't know if you've seen that on...
We saw that at, remember Building 302?
Yep.
When we were on that together?
Yep.
We were finding, like a toilet seat, people had stood around the screw,
Yeah.
and so the membrane went whoop, and then you can't see that, and it was covered in ballast, and then it was like a toilet seat.
Yeah,
because
right.
it had come through and then gone back.
Yeah, wow.
Yeah, so I guess with now it being PIR, you've got the better compressive strength.
Yeah.
And that's not happening.
Okay, another key factor, we think anyway, in designing a robust warm roof and de-risking your warm roof build-up is the insulation type. I guess having the choice of different types of insulation gives you that ability to design around restrictions and things like that. So do you want us to tell us about the type of insulations we use?
Yeah, so in our system, we 99.9% of the time use PIR insulation board, which is a foamed plastic. Benefits of that product, it has really good thermal performance in terms of performance over thickness. It has excellent compressive strength, and compared to other foamed plastics like expanded polystyrene, extruded polystyrene, PIR has improved fire performance. So if you can imagine with warm roofs, we're loading these roofs with a lot, in some situations, a lot of volume of foamed plastic, which technically it's combustible, so you want to make sure that the product that is on that roof, in the event, worst case sort of fire starts, and it could be fire from above or within the building getting up into the build-up, you want to make sure that it won't spread and be propagated.
Add fuel to the fire, so to speak. Yeah.
That's it, and that's where a product like EPS, we don't advocate. So EPS is the stuff that you see packed around your telly when you buy a new TV.
We sometimes call it solid petrol.
Yeah, that's right. Yeah. So our system uses PIR insulation board, and we import it from Belgium, and we've got a lot of test data to support and say what it does do. It actually does. It's been tested. In terms of where it's been used, this project here that we're going to share with you is a Somerset aged care development up in Milldale. And that project there is a large CLT, all CLT project. So it's got a flat upper roof deck and it's got a tapered PIR insulation roof on it. Quite a lot of PIR on that roof, just by way of the design, It's got a ridge running through a lot of the roofs, so naturally that ridge is quite thick in some points. Now, on this particular project, the project fire engineer introduced rockwool, which rockwool is this stuff here, and that is a non-combustible lofted insulation.
Yeah, I think the secret to it's in the name. It's wool made from rock.
That's right. Yeah. So it doesn't burn.
Doesn't burn, yeah.
It doesn't burn. But in terms of compressive strength, it doesn't have the same compressive strength as PIR insulation board.
Right.
So liken it to a really dense yoga mat.
Right.
If you were to lie on it, PIR is like a wooden table. You know what I mean? So it's quite different. But the reason that this was used is, if you go to the detail here, you can see you've got the intertenancy firewalls coming up from inside the building there, hitting the underside of the CLT roof deck. And then in line with that, the project fire engineer stipulated that a section of PIR was swapped out to rockwool. So in principle, the theory is, in the event of there being fire breakout in one of those fire cells and it does get up into the roof, it won't pass up over that firewall.
Got a controlled fire cell, so to speak.
That's it, yeah.
Yeah.
So it gives people time to get out of the building. That's
Yeah.
the key thing, in the event of fire, getting people out of the building.
And just further on this detail here, we've got something on top of the rock wall.
Yeah, so we can't put membrane straight onto this stuff like we can with PIR boards. So there's a cover board, which is a really dense jib board,
Right.
gypsum-based type product.
Again, fireproof.
Yeah,
Yep.
totally. Yeah, and that just adds a bit of grunt to it.
And this detail is obviously all in one. It's quite handy to have. We're also showing the thermally broken mechanical fixings.
The IcoFix fasteners, yeah, and you can see that in this situation is pinning that cover board down through the PIR board, and then that just picks up the substrate below there. Yeah.
So, Thomas, on the with the electronic leak detection system, we're using the conductive foil face of the PIR as the conductor, if you like. Of course, here we've sort of upset the apple cart. We don't have any foil facing over that piece there. How do we get around that piece with your cover board?
We would have to design in a conductive element. So
Right.
underneath the cover board, we would have probably mesh,
Yep.
which 50 by 50 stainless steel grid.
Yeah.
And we would use a conductive ribbon on top.
Okay.
It's not 100% coverage, but
Yep.
it still gives the ability to test electrically with reduced accuracy, but a test all the
Yep.
same.
Yeah.
Okay, just to maintain that electrical conductivity, right? Yeah.
That's bang on.
All right,
Yep.
we're learning every day. Our third key point for today on how to design a robust warm roof solution is to integrate electronic leak detection. So we commonly call it ELD, and your company is called ILD. And do you want to just differentiate the difference there? Do you want to tell us a bit what ILD is?
International Leak Detection is a company started in Germany. EFVM, Electric Field Vector Mapping, is
Right.
the technology.
Yep.
We do that in New Zealand as the representation of this side of the world.
Yep. And for our Australian viewers, our new Australian viewers, you also go
Also
to Australia
there as well,
Yep.
Roberto. He looks after Australia.
Hi, Roberto.
Hi, Roberto.
So, Thomas, do you want to tell us, I guess, briefly how electronic leak detection works, I guess? Give us a rundown on how it all goes.
It started off with mostly concrete
Yep.
substrates.
Which is your conductive
That's
material,
the conductive,
right? Yep.
limited conductivity.
Yep.
What EFVM is doing is putting a current on top of the membrane. So
Yep.
we do this by wetting the surface, not flooding.
Mhm.
We then put a conductive wire around the perimeter of the membrane surface.
Yep.
And we connect that to a generator. That generator pulses roughly 40 volts
Right.
through the moisture that's on the surface.
Yep.
We are then able to read the electricity within that perimeter.
Okay.
If there's no problems with workmanship or damage, the electricity has nowhere to go.
Okay, so I think we've got a slide on slide 6 that shows.
That's it there.
So around the perimeter there, you've got your
That dotted
perimeter
line.
wire, yeah?
Yeah, that's
Yep.
representing the test wire, which is pulsing electricity into the middle. With there being no breaches in the surface there, the electricity, it's held, it's insulated by
It's
that
got nowhere to
membrane.
go,
It's
right?
got- you
Okay.
can't go in. It's like it's wrapped in the wire.
Okay.
Yeah, so that's then we can tell almost instantly, especially on a small surface like a balcony or something like that, the guys can tell this is actually looks like it's been looked after and
Yep.
we don't have any breaches.
So you're using 40 volts and some, I guess, low amperage, so it's safe, yeah?
Very limited
Okay.
amperage, yeah. It gives it wakes you up a little tickle, but yeah, you never do get used to that
Right.
part of it.
Fantastic. Okay, so then what happens if there is a breach or a hole in the membrane, which is acting as your insulator? What do we see then?
We start to see the current moving. So the current now has somewhere to go.
Yep.
And it's trying to leave that perimeter, and it leaves via the water as the conductive medium, and that goes below to the conductive substrate, whether it be the foil from the PIR board or the concrete or the conductive ribbon on top of the rock wall, as we saw before. And
Yep.
then that movement of direction, the guys can triangulate that direction, and they can actually pinpoint the breach. So we could find a breach in the membrane the width of your hair.
Yeah, well, could be handy.
Could be handy. So this is Chris.
Hi, Chris.
Hey, Chris. He's walking the roof here, so you can see that the surface of the membrane is all wet,
Yep.
and there will be a perimeter wire around.
Mm-hmm.
He is measuring the electricity and the direction of his over the roof.
Okay, so by using those poles and looking at his display,
Is that
he can
ammeter
actually depict-
potentiometer?
that'll actually, what's it called, sorry?
We call it an ammeter.
An amp meter. Okay.
Yeah, it's
Right.
just reading.
Yep, yep.
Yeah.
And then from that, he can actually tell which direction to move in to triangulate.
Once
Yeah.
he's actually found something,
Yeah, yeah.
he will triangulate it. But really, the process would be to mow the lawn. That
Right,
allows
right.
the guys to visually see the roof because of the experience they have with testing these roofs. It's not just about that bit of kit. That bit of kit is a tool we use to look over the roof and see how it's going. But really, the guys' experience using their eyes too, they are picking up a lot. So
Right.
it's not a machine that you buy off the shelf.
No.
It's something that we have learned to ride the bike on and deliver that service.
Yeah, nice. So we've got a bit of a video here. Thomas is going to explain with an animation sort of how it all works. Picture says 1,000 words. It saves me talking for the next 10 minutes. So we'll just throw to you, Thomas.
No worries. Pretty typical car sales building. And membrane on top.
Yep.
What we've got is a warm roof there. And the conductive element in this is mesh, but now we have the foil on top of the PIR.
Does the same job, yeah?
Does the same job.
Yep.
This here is just showing that there is no breach in the membrane. The electricity's got nowhere to go.
Yep.
And once the test is going and we have a breach, this is what we're reading. In the mind's eye, this is what's happening.
Yep.
And as they mow the lawn, essentially, they're going to go past these things, and the triangulation, the way that the direction's going, they will be able to work out that these are the spots where the membrane has a breach.
Excellent. I think it's a really good illustration of how it works. And then we're just going, so we write electronic leak detection into our specifications now. It's standard, isn't it?
It is standard.
So if you download a Nuratherm warm roof spec from MasterSpec or our website, congratulations, it automatically comes with electronic leak detection. So what have we changed? What do we do differently now that allows us to, every roof to be electronic tested ready?
Yeah, so it's super simple in the sense that the installer gets a roll of conductive tape that we supply to them, and they run the tape across perpendicular to the board butt join, and that essentially connects the boards, the foil facing of the board together, and they then tape the join tape over top.
Okay.
So essentially you're stitching all the boards together and creating a conductive element that you and your team can then pick up. So yeah, as you say, it's standard with our systems now. You would have to physically take it out of the spec, and not really too sure why you would, but yeah, it's the way to go.
Yeah, you're 99% there with already being foil, you know. You were there already.
So simply by including the tape and the test tags, we're good to go.
Yeah.
So I think we've got a quick illustration on the next slide here that's a bit of a render on how it all goes together.
Yeah, and as you mentioned, the test tag, so we recommend one of those little bad boys, little dog tag thing you can see sticking up there, one every 500 square metres, and that's simply there as a visual ID for Thomas and his team to then pick up, hey, look, we know that there's provision has been made in this warm roof system, and it's good to go for...
And that's where we would connect onto it. So in the concrete element... the electricity is going bang into the concrete, into the reinforcing steel, or creating that potential difference. With this, we are using that tag to be the other side of the circuit. So that lets us touch exactly what's below the membrane right there.
So it's really simple, and coming back to the topic of this chat, it's about ways that you can de-risk your warm roof, and this is bog standard for us now, and it has been for the best part of probably 12 months. With our system.
Absolutely. So that's a very pretty architectural render. We've actually got a real life photo as well, what it actually looks like on site. So this is a sort of thing hopefully Thomas sees. Is the tape installed on the board?
Yep.
And then what we're seeing there is you can't really see it too well because it's all taped over, but you've got that little pipe penetration which has been used for the conductive tags. So the conductive tags tape to the surface of the aluminium, and then the wires run up through that penetration. So that's what they look like in real life.
You're just trying to come out somewhere that's low risk to the water tightness. It's always going to come out a termination of some kind. That may be a skylight underneath that flashing, or the roof hatch.
Upstand or something like that.
Yep.
And it's definitely something to think about for architects and designers designing flat roofs, because often people love the aesthetic of a clean flat roof with no penetrations. So it does pay to think about that, where you're going to locate that. And often there are pipe stacks or solar or something happening that you can attach it to. Yeah.
Bound to be.
Totally.
Bound to be. So how long's the ELD technology been around for?
Probably just over 40 years.
Yep.
Big thing in Europe, I think.
Yep.
It's been here since 2009.
Yeah. So all our systems are manufactured, supplied, and by one European manufacturer, and electronic leak detection is not new to them at all. So it has actually been around a long time.
Just seen snippets of it on Grand Designs UK and that sort of thing from time to time.
Yeah. And I mean, like Scott said, it's been available on our spec for a while now, and we've certainly moved away from the old school flood testing, because there is actually a proper standard for flood testing, isn't there?
Yeah, there is.
However, we just do not recommend it for this particular build-up.
No.
The last thing you want to do is fill up that cavity with water and try and get it out again. And
ideally keep moisture away,
particularly
during construction.
Yeah.
Definitely.
Yeah. And so you've tested a couple of roofs. You've been around a while. You've done a few now.
Yeah.
A couple of thousand square metres. Yeah. Excellent.
Millions of square metres probably.
And what are you typically seeing as the damage points? What's happening? Where are these failure points? When's it happening? Who's responsible?
I think there's a stigma. Where it came from, I'm not sure. But it's always that the waterproofing, the waterproofer, the product is the issue.
Sure.
And we thought that too, because we tried to push that so hard on those people involved that, hey, you should be doing this. And then the more we saw the results of the tests, and it just happened over and over again, it is the construction phase, the traffic.
Yeah.
And where's the waterproofer when this is happening? They've normally
finished by then.
Finished, and they've handed it over back to the main contractor.
So when's the best time to do an electronic leak detection test then?
It would be for the project.
Yeah.
It would be at practical completion.
Okay.
We know there's an element of we want to see a handover from the waterproofer, so the installers is there. But if we have a choice for, hey, look, we've got a limited amount of money and we want to do it at the right time, especially with two-layer torch on, you can do this at the end, after everybody has used this workbench.
Yeah, we see them as a workbench quite often. Yeah. So you're the last trade, I mean, even after the carpet layer, right?
Well, yeah, definitely try and be the last.
So we're always trying to improve the robustness of what we're doing. You go back to the early 80s, we were using single layer membranes. We've now got, we've gone to 2-layer membranes. We're increasing the robustness and built-in redundancy all the time into our systems and things like that. This electronic leak detection is another step. I think it helps designers and specifiers with particular clauses around E2.
So when it comes to that allowance for failure, it's recognising the real place which the membrane is a part of in the construction phase. The allowance for failure is recognising that through sequencing, that 3.7 A and B, the sequencing, the membrane will be there first. And it is nearly inevitable that it will get trafficked on. And there's bound to be damage that happens, something spilled, those sort of things. Allowing for that failure to happen and be located and fixed is mitigating that part of the construction phase that plays, and lends itself to the maintenance side as well. You're able to test into the future of the life.
So once this is installed, you can test any time?
You can test any time. Right. You can pair that tool with your visual inspections that happen on that frequency, and allows that to sort of carry out and perform as it should.
So thanks for joining us today on how we de-risk our warm roof build-up. the key message is that Nuralite can de-risk your warm roof build-up. And the three things we talked about today was the mechanical fixing method, the a la carte insulation types we can use to meet the design brief, and we talked a bit more extensively about electronic leak detection from our fantastic panellist Thomas from ILD. And thanks again to Scott for being here. I know you had no choice, it's your job, but it's good to have you here.
Thank you.
Excellent. And
Appreciate it.
stick around, we'll flip to the Q&A. We'll see you there. And just like that, we're at the Q&A section. So feel free to use the Q&A function at the bottom of your screen there. I've had a few questions come in throughout the presentation, which is great to see. Just a reminder again that at the end of this webinar, a survey will pop up for the NZIA CBD points, like all our webinars, with 5 CBD points for each single one. So there's a whole library back on our website. Just before we kick into the Q&A, we're just going to run a quick poll. So as a specifier, what do you see as the biggest risk to a warm roof? We'll just let that sit there for a moment.
Good idea.
Cool. We'll just, I think we can show the results, I think. Yeah, so out of all those options there, obviously water ingress was the primary thing we're trying to avoid. Right, let's kick into the Q&A. Bear with me. Where are we? Right, so first question here is, with your leak detection, can you leak test the base sheet first, or do you have to wait for the whole system to be installed?
You could definitely do that. It's all about probably pairing the site with what's going to happen next. But yeah, you could take those steps to go, yes, we know the base sheet is good.
Okay.
And yeah, you could definitely do that.
Yeah, right.
Yeah.
Next one here, probably for you, Scott. Typically, how many fixings do you have in the warm roof build-up? How many fixings would we have per square metre?
Per square metre, so that would be 4 fixings, and that gives wind uplift resistance to 4 kPa.
Right.
ULS.
Okay.
Yeah.
This is always, I knew this would come up. What is the approximate additional cost of doing an ELD test?
I would say probably for the testing you're looking around $6-7 a square metre.
Right.
With the way that you guys have done things with having that element already within the system,
Yep.
You're really only dealing with the testing cost post installation and construction phase.
Okay. So if you could only do one test throughout the whole construction phase, we're all budget conscious and we're all sensible people. If you could only do one test, when would you recommend that it gets done?
I would probably say that you do that at right at the end, so that you're checking that the workmanship is all done. There would have been a QA handover earlier on by the waterproofer to the main contractor.
Yep.
But by doing it right at the end, practical completion, us being the last people on the roof, you're able to draw a line in the sand and go, look, we repaired these things, we highlighted these things, and they've been fixed. We're handing over a watertight membrane.
Okay.
Yeah.
A quick one here for you, Scott. I think, what's the longest your fixings can go to?
Longest fixing would be the flange.
Yep.
The longest we can do there is about, I think, 1.8
Yep.
metres.
Yep.
Yeah, which is,
Very,
if you're
very,
doing
very
a
long.
warm roof that thick,
Yeah.
there is an issue.
Yeah.
Probably look at redesigning your drainage layout, or something is happening there. Yeah, that's
just to try and minimise that volume, right?
That's
Yeah,
thick,
yeah,
and with that massive of PIR comes dollars.
Yeah.
For
So
sure.
we try and be
Cost.
common sensible about these things.
Totally. Yeah.
Another one here. Do you have to do your test after a prolonged period of rain?
That definitely helps, but we in the test process we wet the roof. That might be via a hose, or yes, if it's the rain works well for us. We can test in the rain. Yeah, that works great. Yeah, but that helps also. If it had been raining for a long time, we know that we're going to get a great test result.
Okay. So this is a good point, I think. I've got a designer here who said that. So given many of the leaks happen at junctions and whatnot, how do you test around the perimeter? If you've got a wire around the perimeter, how do you test sort of outside that where you've got transitions and terminations?
Yeah, good question. Maybe some trade secrets going away here, but it's the control of the water.
Right.
So if we are able to control where the water goes and everything else is dry around, the electricity is only going to go where the water goes. So if we can control where, even testing outside the wire, the electricity can only go where that wetness is, and so we can go to the extremities of the termination.
Okay. What are the types of membranes you can test?
We can test all membranes apart from EPDM. So that is, and the reason why that is because that contains carbon, and that it isn't a insulator of electricity.
Conductor, right? Yeah. Okay. Good. A lot of questions here. Look, if we don't get time to run through all the questions and answer them all, everyone who's registered today will get a copy of this webinar to hang on their wall. They'll also get a full copy of the Q&A that we'll have answered and we'll send out as well. So don't apologise if we don't get to your questions. There's quite a few coming in. What's the next one here? Sorry. Can we use EPS insulation in a warm roof build-up?
We would say no. Would recommend against it. Yeah, for the reasons that we touched on earlier. EPS is extremely flammable. Can take on moisture more compared to PIR, and has lesser compressive strength. So we would say no. Okay.
Got a question here about connecting the connector plate. How it's positioned. So we're talking about the dog tag or the connector plate. I might be able to try and explain this better. So basically what it is, it's a conductive wire. So this element is stuck to the aluminium foil of the warm roof. This then carries the current outside the membrane, and it's typically dressed up a penetration or an upstand that's waterproof anyway. And this gives you something to connect onto.
Yeah, that just allows me to
conduct the test,
I get to touch what's behind the membrane as well as putting a current on top, and then I'm just... The leak is the connection point between those two things.
And these are literally $17 each. They're pretty economical. We recommend one per 500 square metres. However, you can put as many as you like in at different situations, or if you're compartmentalising your roof, you can put it in different compartments.
We see with that as well, the night seal thing. Can also be, they just can't reopen, or they don't want to reopen that area. So look, just put another plate in, and we'll just test it in area 1, area 2.
So we're giving away a little secret of what's happening in part 2. So this is a multi-part webinar. This is the first part. The second part, we're actually going to talk about the same topic, how to make robust warm roofs. But we're going to touch on the 3 things around allowance for failure by having an outlet in the substrate. Compartmentalising your warm roofs, and how to create bulletproof penetrations, and specific examples around solar panels. So that's the next webinar. So we're going to leave you with that. Like I said, we'll follow up with the full Q&A. We'll answer all the questions that have come through. We haven't really got time to sit here and answer them all. I'd love to. And we're just going to finish up with a poll. If you're currently working on a project right now and you'd like someone from the team to reach out, feel free to give us a yell and we'll reach out to you, see if we can help you out, or if you've got a specific question. Until then, we'll see you on the next webinar, probably in about 4 weeks' time. And ka kite and take care.